here here we have a function z. It's a function x and y, which is sine xy. So if you wanted to find partial z, partial x, you have to consider x as your main variable, and y here is a number. So derivative of sine xy is cosine xy times derivative of what inside, derivative what inside with respect to x. So derivative x is 1, and you have to copy paste y here. So partial z partial x is y cosine xy. Partial z partial y, again derivative of this function sine xy is cosine xy times the derivative what inside with respect to y. Derivative of y is 1, so you have to write x here. If you wanted to find the second derivative partial to z partial x squared, you have to work on partial z partial x. You have to find the derivative of this function one more time. So with respect to x, so derivative of cosine is negative sine xy times derivative what inside with respect to y. So derivative xy is x because derivative y is 1, and you have to write, derivative of this function with respect to x is y, and y times y, which is outside, equals y squared. Partial to z partial y squared, you have to work on partial z partial y here. You have to find the second derivative from here. Derivative of cosine xy is negative sine xy, and the derivative here with respect to y, so derivative what inside with respect to y is x, so x times x equals x squared. Partial to z partial x partial y, you can write it in the form partial x partial z partial y. Here we have partial x partial z partial y from the previous steps equals x cosine y. Now you have to find partial x of x cosine xy. You have a product here, so you have to apply the product rule, because here x times cosine xy, x here is in the first and in the second, so it is a product rule. You have to apply the product rule. First times the derivative of the second, cosine xy, its derivative with respect to x is negative sine xy times the derivative what inside with respect to x, which is y, plus derivative of the first, which is 1, times second, which is cosine xy. And you can simplify your problem to be negative xy sine xy plus cosine xy. If you wanted to find partial to z partial y partial z, you can write it in the form partial y of partial z partial x. We know that partial z partial x from the previous steps is y cosine xy. Now you have to find the partial y of y cosine xy. So you have a product here, a product between y and cosine xy, because we are working with y here. So first times the derivative of the second, derivative cosine xy is negative x sine xy, plus derivative of the first, which is 1, times the second, which is cosine xy. And you can simplify your problem to be here negative xy sine xy plus cosine xy. Another example, here we have a function fxy. We want to find the second partial derivatives. So we have to find the first derivatives fx, or partial f partial x. So we are working with x only. So derivative x power 3 is 3x squared. Derivative x squared y power 3, y here is a constant because it is a partial derivative with respect to x only. So we have to treat y as a number. X squared is, its derivative is 2x, and y power 3, you have to copy paste it. This term doesn't include x, so its derivative equals 0. Fy, the derivative of f with respect to y, here there is no y, so its derivative 0. Here we have a y here, so its derivative is 3y squared times x squared, and derivative of negative 2y squared, put the power down and subtract 1 from the power, so you have negative 4y. To find the second derivative, fxx, or partial x, the second derivative here, so you have to find fx. This is fx from the previous step. You have to find partial x one more time for f of x. So the derivative here is 6x plus 2xy power 3. And fxy can be written as partial y, the partial derivative with respect to y of fx. Fx from the previous steps in the previous slide equals 3x squared plus 2y power 3. So you have to find the derivative with respect to 2y here. Here there is no y, so its derivative 0. And here y power 3, its derivative is 6. Y power 2 times x. So this is your final answer. And by the way, fyx must equal the result of fxy. So partial, here we have partial x. You can write fyx as partial x of fy. This is fy from the previous steps. Find the partial x. So derivative here with respect to x, it is 6x y power 2, and there is no x here, so its derivative equals 0. The same answer. F double y, or partial 2 or partial y of 3x squared y squared minus 4y. This is fy from the previous step. From the previous steps we have fy here, and here we have partial y. You have to find the derivative with respect to y. So here y power 2, its derivative is 2 y, 2 times 3, which is 6, and x power 2 is a constant because we are working here with y, times y here. Derivative of negative 4y is negative 4. And now with the multivariable chain rule, if you have u is a function x and y, which is root x plus y, and x is a function in s and t, which is s squared plus t squared, y is a function in s and t, which is 2st. We have to find the partial u, partial x. Actually, partial u, partial x, you can write the rule here. Partial u, partial x is partial u, partial x times partial x, partial x. And here, partial u, partial y times partial y, partial s. So we have to find partial y, partial x, partial s, partial u, partial y, partial s. Here we have partial u, partial x, which means that the derivative of u with respect to x, the derivative of u with respect to x, the derivative of the root with respect to x. We know that from the table of the derivatives, derivative of the root is 1 over 2 the root times the derivative what inside with respect to x. So derivative of x is 1, and y, its derivative is 0 because we are working here with x. So you can write 1 over, substitute x and y, here x is s squared plus t squared and y is 2st. Substitute here by x and y, and you can simplify your problem, and finally we have 1 over 2 square root s plus t all squared, and finally we have 1 over 2 absolute s plus t. And similarly here you can find the partial u, partial y. Partial u, partial y, so the derivative of the root, 1 over the root times the derivative what inside the root with respect to y, which is 1. And similarly you can substitute x and y here, and this is your final answer. Partial x, partial s, partial x, partial s. So you have to consider s as a variable here and t as a number. So the result is 2s. Partial y, partial s, partial y with respect to s. So it is 2t. And now substitute in this rule and simplify to get your final answer. We have some applications for the partial derivatives like Laplace equation and harmonic functions. For example, here, if you have u, x and y is a function in x and y, which is e power x sine y, show that this function is a solution of Laplace equation u double x plus u double y equals 0. First of all, you have to find ux, the derivative of this function with respect to x. So e power x, its derivative is e power x, and sin y is a constant. Uy, the derivative of this function with respect to y. So it is e power x, derivative sine y is cosine y. U double x, the derivative of, you have to work here, the derivative of e power x sine y, because we need u double x, you have to find the derivative one more time here. So it will be e power x its derivative e power x, and sine y is a constant. U double y, you have to work on this uy, e power x cosine y. The derivative of cosine y is negative sine y, and e power x is a constant. Now find u double x plus u double y, and the final answer is 0. So we have shown that u is a solution of this equation. We have some applications also in the wave equation. For example, if you have ux and t is sine x minus at, verify that this function satisfies the wave equation u double t equals a squared u double x. So similarly, you can find ux derivative of ux, here u, derivative of u with respect to x, the derivative of sine x minus at is cosine x minus at times the derivative what inside with respect to x, which is 1. U double x, derivative of this function with respect to x, so derivative cosine is negative sine x minus at times derivative what inside, which is 1. Ut, derivative of this function with respect to t, derivative sine x minus at is negative a cosine at, negative a because derivative of what inside with respect to t is negative a. U double t, you have to work on ut here. Derivative of cosine is negative sine. Derivative of cosine x minus at is negative sine x minus at times the derivative what inside with respect to t, which is negative a. So we have here, which is negative a, and we have here so we u double t equals negative a squared sine x minus at, and you can notice that u double x is negative sine x minus at, so you can replace negative sine x minus at by u double x, and a squared is here. So we have u double t, we have proved that u double t equals a squared u double x.